Example 5.1 Standardizing skiing times. The men's super combined skiing event debuted in the 2010 Winter Olympics in Vancouver. It consists of two races, a downhill and a slalom. Times for the two events are added together and the skier with with the lowest total time wins. At Vancouver, the mean slalom time was 52.67 seconds with a standard deviation of 1.614 seconds. The mean downhill time was 116.26 seconds with a standard deviation of 1.914 seconds. Brode Miller of the United States, who won the gold medal with a combined time of 164.62 seconds, skied the slalom in 51.01 seconds and the downhill in 113.91 seconds. Question: on which race did he do better compared to the competition? And that's key words here. Compared to the competition. So, what do I need to know? I need to know how the competition did. And there are two values that tell me how the competition did. So let's take the first race, the mean slalom scores. So the slalom had a mean time of 56.7 seconds, or 52.67, and a standard deviation of 1.614 seconds. So what does that allow us to do? So that means basically, on average, the average person making that race did it in 52.67 seconds. However, the standard deviation explains to me how spread out that data is with a standard deviation of 1.614 seconds. So let's look at Brode Miller's scores for that. He skied the slalom in 51.01 seconds. And what we're going to do in this situation is take a look at a z-score. So, give me just 1 second. Okay. So here is our formula for z-scores. And a z-score takes any measurement minus the mean of that measurement divided by the standard deviation. So we're going to go ahead and do that calculation right now. So what we have here is he skied the slalom. His score was 51.01. The mean score was 52.67, giving him and has standard deviation of 1.614 seconds. I'm going to grab my calculator to do the calculations. Give me just 1 second. Okay, so hang on 1 second. So my calculator. I'm going to do 51.01. It's very important that if you're going to try to do this all in one step to do parentheses, you can. However, I generally would avoid doing that. 52.6. Oops. Because if you don't do this correctly, you'll easily make a mistake. 66 over 1.614. And the fact that it's negative means his value is less than the average, which makes sense because you're trying to go faster. You want to have your speed faster, which means less time than the competition. And we're going to divide that by 1.614. And that's the z-score we're looking for. I'm going to just round this to the thousandths place, so negative 1.029. approximately, rounded to the thousands place. Okay, now we're going to look at the second race. Let's do that in blue. That has a mean time of 116 seconds with a standard deviation of 1.91. And how did he personally do in that? Brode Miller did that himself in 113.91 seconds. So again, we're going to calculate the second z-score same way. We're going to take his score minus the average mean score, which is 116.26, and we're going to divide that by the standard deviation, which is 1.914. So, again, pull out the calculator. And this is my numerator. Notice it's negative because he's still doing better than the average person in this particular race. And we have, I'm going to round this again to the thousands place, which would be negative 1.228. Now, let's get a visual reference on this so we can really understand what's happening. And to do that visual reference, I'm going to bring in a little graph here of the z distribution. Oops, hang on a second. I'm actually going to, oops, don't want that. Bring in two images. Just make two of them. Paste one there. And one directly below it. And what I want to do, line these up as best as I can. Okay, so the first one, we're looking at negative z-scores. And if you look at this graph, basically what you're looking on a normal distribution is everyone's data plotted out with the average being right there in the middle. So if he did exactly in the middle of all of those skiers, he would have a z-score of 0, but he didn't. He was faster, which means a faster time, smaller z-score. We'll actually do the green one first, so let me color code that so there's no mistake in what I'm doing. So that's the mean, and he was faster. His z-score is right about here. Negative 1.029, which means very, very few people did faster than him on that one race. And again, there's two different races, so you could do really well on one and not so well on the other. That's why they add the times together. And on the other race, however, his score is 1.22, which puts it over here. And the further you go over here, the less people beat you. So he did much better over here because there's a smaller group or area under that distribution that would have been faster than him. And that's how we come up with that calculation.